So in this video, we're going to check for linear independence this set of solutions here: e to the x, e to the 3x, and e to the 7x. Now what I'm going to do is I'm going to turn these into a matrix called the Wronskian, and if the determinant of that matrix is not 0, then we know that these solutions are linearly independent. Now that works in a lot of cases, so I'm going to show you how we do the Wronskian for these 3 solutions here. So what we do is the Wronskian, we call it the variable w of x equals the determinant of a 3 by 3 matrix. We list these 3 terms at the top of our matrix. So we've got e to the x, e to the 3x, and e to the 7x. And then on each row underneath, we take the derivative each time. So derivative of e to the x is e to the x, derivative of that is 3e to the 3x, and this one 7e to the 7x. And we need to make this a square matrix, so we then need to do one more row. So here we go, next derivative, e to the x, 9e to the 3x, and here's 49e to the 7x. So now we need to find the determinant of this matrix. So first of all, let's take this term in the top left. So we've got e to the x, and then we do the determinant of this matrix here. So we've got 3e to the 3x, 7e to the 7x, 9e to the 3x, and 49e to the 7x, and then subtract it using this term, e to the 3x, and we want the determinant of a 2 by 2 matrix made of these 2 terms. So e to the x, 7e to the 7x, e to the x, and 49e to the 7x. And then finally we take this term here, e to the 7x, and then the determinant of this 2 by 2 here. So now we've got e to the x, 3e to the 3x, e to the x, and 9e to the 3x. Okay, right, let's find the determinant of all these 2 by 2s and multiply it by this, what would become a coefficient, basically e to the x. So now we've got e to the x, and we're going to, so now 3 49s are 147, and 3 plus 7 is 10. So I've got 147e to the 10x minus this line here multiplies, so 7 9s are 63, and e to the 10x. And then we subtract e to the 3x multiplied by this diagonal multiplied together, so 49 times 1 is 49, and 8x. So that's 49e to the 8x. And then I've got 7 1s are 7, so 7e to the 8x. And then here add e to the 7x, and now I'm going to have 9e to the 4x and 3e to the 4x. Okay, right, let's simplify what we've got here. So this times e to the x is 147 e to the 11x minus 63 e to the 11x. And here I've got minus e to 3x times this. So now I've got minus 49 e to the 11x. And then minus times a minus is plus, so that's 7e to the 11x. And e to the 7x times 9e to the 4x. So that's going to give me 9e to the 11x, and that's plus. And here I've got e to the 7x minus 3e to the 4x. That's minus 3e to the 11x. Okay, right, well, they're all e to the 11x. So then what I'm going to get is e to the 11x multiplied by 147 minus 63, which gives me 84, minus 49, which gives me 35, plus 7 is 42, plus 9 is 51, and minus 3 gives me 48. So all that becomes 48. So then I've got 48e to the 11x, and this is not going to be 0. Does not equal 0. So then with the Wronskian, we've now shown that this is linearly independent. Okay,